Namaste and a very, very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun, and in today's presentation, we'll be looking at how to detect multicollinearity by looking at a correlation matrix. In my last video, we looked at a series of metrics which can help us detect multicollinearity. The question is there a simpler way of detecting multicollinearity? To answer this question, I will be using a data set called as car sales. And from car sales, we will be generating the correlation matrix. We will take it to Excel and produce a heat map. And through a heat map, we will be able to easily decipher whether there is the problem of multicollinearity in the data set or not. What you're seeing in front of your screen is SPSS. I will access the data set. To access any data set, you can click on the file menu, choose the second option, open, and here I will choose the first item, data. Right now, I am in the English folder. There are a whole lot of files in SPSS. I will choose the file car sales. This is the file which I want to use. Yes, this is the file called as car sales. You see details about different personal vehicles. You have the manufacturer of the car, you have different models of the vehicles like Integra, TL, CL, so on and so forth. Some description about sales value, resale value, the type of the vehicle, price, engine size, horsepower, so on and so forth are given. All these are good variables. What is the sample size in this data set? When I scroll down, I see that the sample size is 157. So you have 157 records. Here, the problem is to check whether there is intercorrelation or interrelationship amongst certain independent variables. If you are choosing sales as the dependent variable and other vehicles and other variables like resale value, price, engine size, horsepower as independent variables, we want to be able to conclusively state, yes, the independent variables are uncorrelated. How do we check whether the independent variables that I've highlighted here suffers from multicollinearity or not? To check whether or not this particular data set has multicollinearity, what I will do is I will perform a very, very simple analysis. I will generate the correlation matrix. How do we generate the correlation matrix? I'll go to analyze. Popularly, people use correlate option. I will not be choosing the correlate option. There is a simpler way of doing this, and that is to look at dimension reduction. And here, there are different options that are given. The very first option is factor. The purpose of this particular video is not to show you factor analysis, but I just want to use one of the features that is present within the factor analysis option to produce the correlation matrix. Here, you can see the list of variables that we have in the canvas on the left-hand side. I will be choosing only my independent variables. Sales is my dependent variable, so I'll ignore it. I'll choose the variables from 4-year resale value all the way up to mileage per gallon. I want to detect whether these variables have interrelationship amongst themselves or not. To find this out, what I'll do is the very first tab is what is called as descriptives tab. Once I click on this, the descriptives dialog box opens up. By default, it will give me the initial solution. I'm not interested in looking at the initial solution. I want to keep it very, very simple. And therefore, I'll click on the option which says coefficients. This will give me the correlation coefficients in the form of a matrix. I'm just interested in generating the correlation matrix, nothing else. Let me click on the option continue and then say OK. What this does is it just runs a factor analysis output. I'm not interested in looking at the output of factor analysis. I just am interested in this particular matrix which says correlation matrix. This is very, very useful because It is just giving me the correlation matrix. I'm not getting the significance level. I'm not getting the sample size and such things that you would get when you would use a bivariate correlation. So you can see approximately 100 numbers here. So it becomes very, very difficult to visually say whether or not there is high relationship or low relationship among some of these variables. Is there a simpler way of depicting the same thing? To simplify this, what I will do is I will select the particular matrix, right click on this and choose the second option, which is called copy. Let me copy this particular correlation matrix, open up an Excel sheet and paste this particular matrix. So this is the correlation matrix. It's a lot easier to visualize a correlation matrix using Excel rather than SPSS output window. What I'll do at this stage is to remove the merge option as well as wrap text. This is how the numbers look like. Let me zoom in for better visibility. So these are some of my numbers. At this stage, what I will do is there is an option called as conditional formatting in Excel. You can see this option, conditional formatting. Within this conditional formatting, the fourth option from the top is color scales. You can choose the very first option, green, yellow, and red color. The moment I choose conditional formatting, you can see the numbers get highlighted in different colors. A simple thumb rule is wherever you see deep red color, darker the red color, it means that there is a strong negative relationship between the variables. Wherever you see dark green colored cells, it means that there is a strong positive relationship between the variables. And wherever you see yellow colored cells, it means that there is a moderate relationship between the variables. Now, some of the eye-catching numbers that I see here would be this bunch of cells. So let me just highlight them. You can see a lot of cells here are greenish in color. Some of them, of course, are yellowish as well. Now, these variables are width, sorry, this is wheelbase, width, length, curb weight, and fuel capacity. There is strong positive relationship amongst a lot of these variables. You can see here 0.854. As you know, correlation value always lies between -1 and +1. If the values are close to +1, it means that there is a strong positive relationship. On the other hand, if the values are close to -1, it means that there is a strong negative relationship. Values greater than 0.7 indicate strong relationship. When you look at some of these values, 0.854, 0.67, 0.65, 0.74, 0.73, again you see 0.84, 0.73, 0.74, so on and so forth. This indicates that there is a lot of positive interrelationship amongst variables like wheelbase, width, length, curb weight, and fuel capacity. This further points out to the problem of multicollinearity. What is multicollinearity? Interrelationship amongst the independent variables leads to the problem of multicollinearity. Why should I worry about multicollinearity? I should worry about multicollinearity because if my data set suffers from the problem of multicollinearity, I will not be able to trust the coefficients of the variables. My standard error will be very, very high. The confidence interval will be wider. And it further leads to the problem of overfitting. Multicollinearity leads to the problem of overfitting. So here, through this simple technique of conditional formatting, we will be able to identify strong positive relationships. Equally, you see a lot of dark red color cells. Now, all these variables correspond to fuel efficiency, which means that fuel efficiency shares a negative relationship with many variables. what are eye-catching numbers? Some of the eye-catching numbers would be minus 0.725 with engine size. Similarly, you can see numbers like minus 0.6, minus 0.819, minus 0.809. All these are indicators that there is interrelationship amongst several variables with that of fuel efficiency. Fuel efficiency shares a negative relationship with a lot of variables. Further, when I look at this set of numbers, what you again see is big numbers like 0.95, 0.77, 0.853, 0.862. So again, this is a pointer to the fact that there is strong positive relationship. So at least I see three set of variables, this being the first set which I've highlighted. This is the second set of variables which have strong relationship, and this is the third set which have relationship with fuel efficiency. So what is my conclusion? Through this simple correlation matrix, I can conclude that the variables related to vehicle characteristic have strong correlation between themselves, indicating that this set suffers from strong multicollinearity. There is a serious problem of multicollinearity in this data set. So to summarize the discussion that we have had, in this video, we have generated a correlation matrix. Based on the correlation matrix, we have exported the output in Excel, and using Excel conditional formatting, we are able to highlight some of these cells which have a strong positive relationship. Green colored cells indicate strong positive relationship. Dark red colored cells indicate strong negative relationship. So visually, we can identify whether or not there is multicollinearity in my data set. With this, I have come to the end of today's presentation. I request you to subscribe to my channel and share this particular video with your friends and relatives. Thank you very much. Have a good day.